Yeah, so good morning, Vineet sir and Farhan sir, and good morning everyone else once again. So now let us start from uh, where we were in the last class. Okay, now so in the last class that we did, uh, I think not in this week, last week. Or maybe last to last week. In that we were discussing about the uh, formation of the earth and shape of the earth, and these were the things that we tried to cover, right? And I believe everyone is clear with the things that we tried to cover in those classes. Okay, yeah, so I'll just do a very quick recap for all of you to let us, all of us be on the same page and recall what we did in the last class. So we were talking of the formation of the earth, and in this formation of earth part we started from 5.6. Very quick recap for all of you. Okay, in this we started with just give me a moment. Okay, so we started with 5.6 billion years before present, when the sun and earth started forming. Okay, started forming, and from there we came up to 4.6 billion years before present. Earth formed. Okay, and it was barren, and first atmosphere was there. Now, first atmosphere made up of hydrogen and helium. Very quick window, right? And then around so first atmosphere, hydrogen and helium was lost. Then after that we came to 4.44 billion years before present, where we had a collision gave present earth and moon. Present earth and moon. Okay, and then on the present earth we had formation of second atmosphere. We directly did due to the volcanism. Okay, and oceans and land or continents and sea floor. Okay, sea floor formation. All of this happened by 4 billion years before present. All of this was there. Is the voice breaking? No. Very perfectly fine. Now, Now, okay. So, around 4 billion years before present, this happened, and then we came to 3.8 billion years before present when life evolved in oceans. This also we understood the whole sequence. And then around 3 to 2.5 billion years before present, photosynthesizing organisms evolved in oceans, okay, producing O2 and consuming CO2. Okay, so this also started happening around this 3 to 2.5 billion years before present. Okay, and then around 500 million years before present, which is 0.5 billion years before present. Okay, life started evolving on land or continents. Land or continents. So life started evolving on land or continents, okay, around this time. And then more O2 produced and CO2 reduced, and we reached the present state of Earth. Okay, so this was the whole Earth story that we did, and hopefully this much was clear to all of you. Okay, right. Something like this. Right. So this was the sequence in which evolution of Earth proceeded from past to present, and this is where we left the Earth story. So we understood that the Earth was formed the way we have with life and oxygen, and this was the third atmosphere. So this gave us third atmosphere, third present atmosphere. Okay. So this is how this whole story proceeded. And this much I believe is clear with most of you. And Harsh, I hope you have also written, and the others also could write this if they need. So this was summarizing what we had done. And then we came to shape of Earth. Shape of Earth, and I would not repeat what we did. This part of the story I wanted to repeat because this was a long story. Shape of the Earth, we understood geometrical and normal shapes or practical shapes, and in geometrical we understood that the shape of the Earth is called as the geometrical shape wise we call it as the oblate spheroid or oblate ellipsoid, and practically out of the shapes that we have we call it as egg-like whatever, and we have given a special name to the shape of the Earth called as geoid. So this much also we have covered. Now once this is covered, now we come to the next part of the story, okay, in our understanding of the Earth. So if you see, by now we have seen the universe story and the the formation of the stars, etc., and all that, and you know, the material and earth and the different regions on the earth, okay, and the shape of the earth. Okay, now if we go in the same sequence, right, following your NCERT, because your NCERTs are the book that I have asked you to follow. So if we, yeah, very good, Geoid, very good, perfect. Okay, so if we go on following the same sequence, then as per your NCERT, after the formation of the earth, the next thing that we come to is the interior of the earth. Okay, and there is one more topic, the magnetism of the earth. So first we understand the interior of the earth, and then we'll go to the next topic of magnetism of the earth. Okay, but before I start with the next topic, that is the interior of the earth, okay, I need to ask all of you that is this much clear to most of you? Is there any major doubt that you have, or is this much clear to all of you? This much is broadly clear to all of you, broadly, right? Minor doubts will be there. Now, in this online mode of class that we are now compelled to do due to the COVID situation that we have at hand, the way we conduct the class is that the portal that you have is given only for giving response of what I ask you. Okay. Right. So on the portal where you are giving me the answers, there you should only be giving answers. Your question should go very good. And I can see all of you writing clear. Very good. Good. Go on writing, because I need this answer from each of you. Is this much clear to all of you? Okay. Now on this portal where you are giving the yes sir, clear sir response, the expectation is that you shouldn't be writing anything else on this portal. If you have any other thing that you want to write, you should write on the classroom coordinator portal. You should send the doubts to your classroom coordinators. They will, Vineet sir and other who are there, right, Farhan, and they will send it to me if needed. Okay, and if you have any technical doubt, that also you should maybe write to them or whichever, but don't write, sir, sound not clear, voice not clear. If there is any problem, the technical team will let me know. So because you are writing something, I will not respond. If you are writing, sir, not visible, not audible, anything, I will not respond, because many times we have seen in many classes, the problem is at the end of the student. His or her internet is not working properly, and because of that, the whole class stops. Okay. So if there is any problem in the internet at our end, the technical team will tell me, and I will stop, but not because you are asking. Okay. So please, if you have any problem, please write to the technical team about, or the classroom coordinators, that I'm not able to see whatever, and refresh your pages and see, but don't write here that audible, not audible, because I can see few of you are responding there. Don't write your doubts also broadly here. Send them to the coordinators. If needed, they will send it to me. Okay, so that the class sequence and the flow remains okay, because otherwise if all of you go on writing lot many things, the class sequence is disturbed. Okay. Right, very good. So I believe all of you are clear with these things. I have not seen any doubt coming from the classroom coordinators or from the students also. Yes, technical team, कुछ issue है तो बताइए. आपने पोर्टल खोला है? Okay, very good. So now let us start with the interior of the earth. Should we? Right. So when we talk of this interior of the earth, okay, the interior of the earth is supposed to make us understand what all things are there inside the earth when we see the inside of the earth, from the surface of the earth to the bottom of the earth, right? When we see inside, what all things do we find inside the earth? Okay, let's go deep inside the earth. Very good. Okay, so yeah, so when we talk of this inside story of the earth, just give me a moment. Yeah. So first of all, we should know what do we mean when we say inside the earth. So this is the earth. This is the center of the earth. Okay, center of the earth. Now from the center of the earth to the surface of the earth, the distance is approximately 6,400 kilometers. It is approximately 6,378 kilometers. So your NCERT though mentions it at something like 6,300 kilometers, but even if you get 6,400 kilometers, that's perfectly fine. Okay, so to the center, the distance from the center to the surface of the earth is around 6,400 kilometers, and the atmosphere that we have around the earth. Okay, what is the thickness of the atmosphere that we have around the earth? Atmosphere. First of all, you should know these things. Okay, what is the different regions on the earth? So when we talk of this atmosphere of the earth, the atmosphere has a thickness of around 3,500 kilometers. This is the atmosphere. Atmosphere. 3,500, and from the center to the land surface of the earth, land surface of earth, from the center to this is 6,400. Now on this earth, we also have the oceans. We know this, that there is a region of the oceans also. So you can say there is a part of the land surface which is covered with oceans. Okay. And we know that nearly 70% of the land is covered with oceans. So what is the thickness of these oceans that we have? Ocean depth. Ocean depth. Ocean average depth is nearly 4.5 kilometers. The ocean average depth is around 4.5 kilometers. Okay. So this is the whole thing. So now when we talk of the interior of the earth, which region are we trying to understand? When we talk of the interior of the earth, the region that we are trying to understand is the region from the land surface to the center. Okay. So if you want, you can write this, that the interior of the earth means the region between the interior of the earth. Once you have put the subheading interior of the earth, हमने लिखा नहीं है ना subheading, let me write this. Interior of earth, that is the subheading that we are now starting. That is given as chapter number 3 of your NCERT. Okay, chapter number 3 of the NCERT. So interior of the earth means the region from the land surface to the center of the earth. Land surface to the center of the earth, having approximately 6,400 kilometer depth. Having approximately 6,400 kilometer depth. Okay, good. Now, when we try to understand this interior, what are the methods to understand the interior? Okay, so methods. Please do write this as the subheading. Methods to understand Earth's interior. Methods to understand Earth's interior. Okay. So now one method is to directly take out things from the Earth interior and try to make sense out of it. Okay, directly getting the material from the interior. Okay, we call this method as direct methods. The first method is direct method. Direct method, where we get the material from the earth interior. You can write direct method, where we get the material, direct method where we get the material directly from inside the earth. Where we get the material directly from inside the earth. Like, how do we get the material directly from inside the earth? Like mining, by mining. Okay. Research, drilling, research based drilling of the earth's surface. Research based drilling of the earth's surface. And third, volcanic activities. Volcanic activity, or volcanoes, you can say. Volcanic activity is a better word. Activity means when volcanoes come out. Okay. So these are the different ways by which we get the material from directly inside the earth. Now, by mining, from what depth do we get the material? Deepest. Direct method. From what depth? If we write from what depth do we get these material? Okay. From what depth? From what depth? From what depth do we get these material in mining? The mining maximum 3 to 4 kilometers. Okay, maximum that we mine is 3, 4, 5 kilometers maximum. We don't go deeper than that. Okay. In research based drilling, maximum we have gone is in the Kola Peninsula, as per your NCERT also. Kola Peninsula. This was a few decades back. Approximately 12 kilometer we have drilled inside the earth to come to know the interior. And let us say if there are some other later projects also, still we might not have gone deeper than 20 kilometers. So the maximum we might have gone is approximately up to 20 kilometers. Okay. So mining 3 to 4 kilometers deep we have dug. Research project, we have got the material from as deep as nearly 12 kilometers or 15 kilometers or 20 kilometers. And when you say the volcanic activity, then we can say magma comes out from maximum, please do write this. Magma comes out from maximum as deep as 400 to 700 kilometers at different places. 400 to 700 kilometers deepest. Okay, so 400 to 700 kilometers out of 6400 kilometers. Out of 6400 kilometers, only 400 to 700 kilometers, which is approximately around, you can say 10%, 11% deep. Okay. So the remaining 90% of the depth, we don't get any material from. There is no way to get the material from the lower 90% of the earth. Okay. There is no way to get the material from. So once you have written this much, then you can write, hence there is no way to get any material from the lower 90%. There is no way to get any material from the lower 90% depth of the earth. Lower 90% depth of the earth, around 5,700 kilometers. Even if we get from 64, from 700, so 64 minus 700, for the lower 5,700 kilometers, there is no method to get any material from. And hence, over 5,700 kilometers. or lower 90% of the material region, there is no method to get any material from. Hence, we cannot use direct methods to understand the interior of the earth. Direct methods to understand the interior of the earth, as direct methods give us a very limited picture. Direct methods give us a very limited picture of the earth's interior. Direct methods give us a very limited picture of the earth's interior, only of the maximum upper 10% of the region. Upper 10% of the region. Okay. So if we can't come to know directly about some region because we can't go there, okay? So what are the other methods that we use? This is where we use the indirect methods to understand the interior of the earth. Indirect methods. We use the indirect methods to understand the interior of the earth. Right? Now, what do we mean by these indirect methods? We need to understand. What are these indirect methods that we use to understand? Okay. So, when we talk of these indirect methods, in the indirect method, you have different aspects, such as the first one are A group. There are different groups. The first is physical characteristics of Earth's interior. Please do write all of them. Physical characteristics of the Earth interior, that is the first group. Then B, study of material or study of, let me use the right word, celestial bodies. Study of celestial bodies around the earth. Around the earth. Why? Because they were also formed along with the earth. Okay. So, because the celestial bodies, other space objects were also formed along with the earth. So, we think that if we can't go inside the earth, we can figure out from the other objects that what kind of material minerals the earth might be made up of. Okay. It is like checking the DNA of your family members if your DNA is not available directly. Okay. So, that will get a sense of what all you are made up of or what are your characteristics, something like this. So, this is how study of the celestial bodies such as Moon, Mars, Venus, other things, meteors, asteroids around us, because they were also formed along with the Earth in the solar system. So, from them also we try to understand the interior. Okay. So, volcanic eruptions, Neha, we have already written, which is the direct method. Okay. Volcanic activities where we have done. So study of celestial bodies around the earth, B, second group, and C is study of energy or forces coming from inside earth, inside the earth. Study of energy or forces coming from inside the earth. Okay. So these are the three groups that we have, right? The physical characteristics, the study of the space objects, and the study of the inside of the earth. Priyanka, I have told, please don't write your doubts on this platform. Okay, please write your doubts on the classroom coordinator. If they want, they will send it to us or me, right? I can't go on reading those long letters that you write. Okay, please do understand. All right, because then the class sequence is broken. Okay, so all right. So study of these three regions. Okay. And please do remember, all of you are now preparing for UPSC civil services. Okay. So you can't have a very childish like, बहुत ही बच्चों के जैसा सवाल नहीं पूछ सकते है ना कि सर अर्थ का ऊपर स्पेस है तो आंसर भी स्पेस होना चाहिए. If we start behaving this way, then things will go haphazard. Okay, that shows that you are not doing very basic reading. So then you have to do some very basic readings also. ठीक है, अगर उस स्टेट पे है तो आई वुड से दैट फॉर एग्जांपल आई सी दिस क्वेश्चन, हमको स्पेस में से अर्थ दिखता है तो अर्थ के डेप्थ में भी स्पेस ही होना चाहिए. So if you have these doubts, I would recommend you people, the ones who have these kind of doubt, that inside the earth also there should be space and all. I would recommend you start reading your class 6th, 7th NCRTs, 5th, 6th, 7th NCRTs about this. Then things will become more, because then, as I told you, some of you might be able to understand from 11, 12, some of you might need very basic books also because you have forgotten those very basics. So please do read those basics also. Okay, the ones who have these kind of doubts. Okay, don't worry, मतलब थोड़ा पढ़ना पड़ सकता है, that's perfectly fine. So you have to study. Okay, if you are preparing for UPSC, then you have to study that part also if you have forgotten. Because these are the things that you learned in very small childhood, that inside the earth there are rocks and all that, magma and all. So अब फिर से बोलोगे सर space होना चाहिए, तो it might. Okay, anyways, so very many times I might avoid those doubts. Study of the indirect method. So first we'll take one by one. So the first one is physical characteristics of the earth interior. Okay, so how do the physical characteristics of the earth interior tell us about the earth's interior? Okay, so you can write. So first we take this physical characteristics of earth interior, how they tell us about the earth's interior. How the physical characteristics tell us about the earth interior. Let us cover that first. Okay, how physical characteristics tell us about the earth interior. So in the physical characteristics, the characteristics that we use, the first one is the temperature characteristic. Temperature of earth's interior. Temperature of earth interior. Temperature. So the first character, and please do write, because I would not dictate all this. The things that I'm writing on the board, I won't dictate. I'm already doing the flow chart here. Okay. So don't expect that later on sir will dictate all this again. These things I will not, because I'm already doing the flow chart. Right? Where I will dictate, I'll tell you that these are the things that I'll dictate later, so don't write. But these are the things that I'm already writing on the board, I expect you to write down. Temperature of the earth's interior. Temperature of earth's interior. So what is the temperature of the earth interior? you can, I want you to note down, write this down, that temperature, you write this way, temperature increases at the rate of, 1 degree Celsius for every 32 meters of depth of Earth from surface of Earth. And whenever we say the word surface of Earth, it always means the land, right? From the land surface, as you go down, increases at the rate of 1 degree for every 32 meters of depth from the depth of Earth from surface of Earth. So as you dig down, the temperature increases by 1 degree for every 32 meters of depth that you dig. Okay, so now, is this okay? So for every 32 meters, the temperature increases by 1 degree, right? And it decreases by this rate, continue to write, it decreases by this rate, not up to the center of the Earth. It decreases by this rate, not up to the center of the Earth. Decreases by this rate, not up to the center of the Earth, and rather by the time we reach the center of the Earth, the maximum temperature as per our present understanding, is around 5,500 degrees Celsius. At Earth's center, temperature is 5,500 degrees Celsius. Okay, and just to help you, it increases. बोर्ड पे increase लिखा है ना? Okay. क्या word लिखा है यहाँ पे? Increases. ठीक है? प्रखर. Okay. At the center, it is 5,500. It is not, if you go by 1 degree every 32 meters, by that rate, it should be something like 2 lakh degrees Celsius. But it is not 2 lakh degree. It does not go on increasing at that rate. Only up to certain depth, it increases at the rate of 1 degree for every 32 meters. After that, it slows down. And it gradually keeps slowing. And by the time you reach the center of the Earth, the temperature is 5,500 degrees Celsius. Now, just to help you remember this temperature, this is also the temperature. Earth center, this is also the temperature on surface of sun. Surface of sun. Okay, so surface of sun also has the same temperature, 5,500 degrees Celsius, and outer most surface of atmosphere, of Earth's atmosphere, outermost surface of Earth's atmosphere, 3,500 kilometers from the surface of the Earth, outermost surface of the Earth's atmosphere, even that has this temperature only, 5,500 degrees. So this temperature, 5,500 degrees Celsius, somehow, coincidentally, is there at the center of the earth, at the top of the atmosphere of the earth, and at the surface of the sun. At all these three places, the temperature is same, just to help you remember. Okay, this is just to help you memorize. Okay, now from this temperature, if you want, you can write, hence from the temperature of the interior of the earth, hence from the temperature of the interior of the earth, from the temperature of the interior of the earth, we can broadly understand we can broadly understand we can broadly understand the state of the matter inside the earth. State of the matter inside the earth. We can understand the state of the matter inside the earth. What state the matter inside the earth must be at. For example, at 5500 degrees Celsius, or as different regions, what state the matter must be at. So this is something that the temperature of the interior tells us. Okay, then same ways. Next thing. So this was about the temperature of the interior. Now same ways, physical characteristics of the earth interior. In this, the second aspect that we have under this physical characteristics of the earth interior, the second thing about the earth interior is the density of the earth's interior. Okay. The second one is the density. Density of Earth's interior. What is the density of the Earth's interior? So when we talk of the density of the Earth's interior, how will we come to know the density? We'll get the rock material from different regions and we can get the density. So what we find is that the continental rock density, the continental rock density is 2.7, please do write all this, 2.7 grams per centimeter cube. 2.7, write this way. 2.7 grams per centimeter cube. Right, the continental rock density is around 2.7 grams per centimeter cube. Then the ocean floor rock density. Ocean floor rock density is 3 grams per centimeter cube, and this data is given wrong in your NCERT. Opposite, ocean floor they have given 2.7, continents they have given 3. That is wrong in the NCERT, so please correct it. This is the right data. Continental rock density is 2.7, oceanic floor rock density is 3 grams, and interior rocks brought by volcanoes, right? Not very much inside. Volcanoes, I hope you remember, we have written volcanoes bring the rocks only from the depth of not more than 400 kilometers. So some interior rocks, okay, as you go below the ocean floor, right? Ocean floor rocks, when you go below that, some interior rocks, they have a density of around 3.3 grams, which are brought by volcanoes, etc. And they are also not coming from too much depth. Interior rocks brought by volcanoes. Yes, opposite. So that you have to correct, Ananya. The data in the NCERT is opposite. You have to correct the NCERT data. NCERT is wrong. Okay. Interior rocks brought by volcanoes, their density is 3.3 grams per centimeter cube. And all of this is the density of the upper region only, because even these are not coming from too much depth. Okay, not coming from too much depth. Some depth, few maybe 100 kilometer depth or so, 100 to 200 kilometer depth. These volcano rocks. Okay, you can say maybe 100 to 200 kilometers depth, because volcanoes do not bring too much rocks from much inside. So this is the rock. Okay, clear? Now, what is the other thing? Then, from the Earth's next point, please do write. Now, from calculation of Earth's total mass, Earth's total weight, you write this way, Earth's total weight, calculation of Earth's total weight and volume. We can calculate the total weight and volume of the Earth. Weight, how can we calculate the total weight of the Earth? From the gravitational force equation. If you want, you can write. That is physics. How we calculate from gravitational force equation, you read in your physics, or you Google, or you find in your science books. I will not explain. Right, so from the gravitational force equation, we can calculate the weight of the Earth and the volume from the shape of the Earth. Okay, the shape of the Earth and the radius of the Earth we know, and the shape of the Earth. So from that we can calculate the volume. From calculation of Earth's total weight and volume, so once you get the total weight, calculation of the total weight using gravity's equation, and calculation of total volume using shape of the Earth and the radius of the Earth, we can calculate Earth's density. We can calculate Earth's density, which is equal to weight upon volume. Weight upon volume. So we have calculated the weight and we have calculated the volume, and hence we have calculated the density of the Earth. What? Calculate average density. Average density, average Earth's density. We have calculated average Earth's density. Earth's average density would be a better word to write. The sequence would be like that. Earth's average density. Earth's average density is equal to weight upon volume. And this we have calculated to be around 5.5 grams. 5.5 grams per centimeter cube. This we have calculated as this. The Earth's average density Earth's average density is calculated at 5.5 grams per centimeter cube. So we have calculated that the average density of the Earth is 5.5 grams. Is this okay? Please do write. Full stop. Next line, once you have written this much, then write Earth's average density is 5.5 grams per centimeter cube. Then write down. Hence, because the Earth's upper parts of the interior, because the Earth's upper parts of the interior, because the Earth's upper parts of the interior have lesser density, Earth's upper parts of the interior have lesser density, within bracket 2.73 or 3.3 grams per centimeter cube, within bracket 2.73 or 3.3 grams per centimeter cube, bracket close. And the average Earth density is 5.5 grams per centimeter cube, and the average Earth's density is 5.5 grams per centimeter cube. Comma, hence, this way we have been able to calculate the density around the center of the Earth. So from this average, we have been able to calculate the density around the center of the Earth. Around the center of the Earth, which should be around 13 grams per centimeter cube. Which should be around 13 grams per centimeter cube. Density around Earth's center would be around 13 grams per centimeter cube. Okay, so you know the temperature at the Earth center, 5,500 degrees Celsius. You know the density at the Earth center, around 13 grams per centimeter cube. I hope you get it. Okay. 13 grams per centimeter cube, right? Full stop. Hence, from these temperature and density, we can also calculate the pressure from the temperature and density. We can also calculate the pressure inside the Earth. Hence, from these temperature and density, we can also calculate the pressure. In the interior of the Earth. Pressure in the interior of the Earth. And by knowing the temperature, pressure and density, and by knowing the temperature, pressure and density, temperature, pressure and density, we can predict which elements we can predict, which elements or minerals, which elements or minerals should be found in the Earth's interior. We can predict which minerals or elements should be found in the Earth interior. And what should be their state? What should be their state? What should be their state? Okay. What should be their state? So if you see from the physical characteristics of Earth interior, temperature, density, pressure, what can we say? So you can write hence this is how the first indirect method, this is how the first indirect method, which was the physical characteristics of the Earth interior, the first indirect method, which was the physical characteristics of the Earth interior, helps us in understanding this one, the physical characteristic of the Earth interior, this one. Okay, helps us in understanding about the Earth's interior. Okay, so this is how the physical characteristics, temperature, pressure and density help us in understanding the Earth interior. Clear? Now, the second, which is the second indirect method? The second indirect method is the study of celestial bodies. So let us see how that helps us in understanding the Earth's interior. Study of celestial bodies. This one. The second indirect method. Study of celestial bodies. How the study of celestial bodies helps us, the second indirect method, how the study of celestial bodies help us to understand the interior. Now let us understand this. Okay, so you can write this. Next paragraph. The study of celestial bodies also helps us in understanding interior. The study of celestial bodies also helps us in understanding the interior. It is very simple. So as I will dictate, you will understand. Okay. Also helps us in understanding the interior because the objects around the earth were formed along with and by similar processes as the earth, were formed along with and by similar processes as the earth, such as the meteors, meteor, meteors, which sometimes fall on the earth from the space, meteors which fall on the earth from the space, the asteroids, asteroids ASTEROID, asteroids found between the Mars and the Jupiter, because they are broken, so by studying them we can understand. Next, material from the moon or study of the moon, Venus, study of the moon, Venus, Mars, and other planets. And other planets, as all of them were formed along with the Earth. Along with the Earth. And by similar processes. Okay, so this is how these celestial body studies help us in understanding the interior of the Earth. Alright? Clear? Now, from the celestial bodies, then we come to the third. The third indirect method, next subheading, or sorry, next paragraph. The third indirect method, which is the study of the energy or forces, coming from inside the Earth. The third indirect method, which is the study of energy or forces coming from inside the Earth. Also help us. Now, which are the energy or forces which come from inside the Earth? There are mainly three energy sources or forces that we get from inside the Earth. Three. Okay, which are the energy or forces coming from inside the Earth? So these are the three. Which are the three? The first one is gravitational force. Okay. The second one is Earth's magnetic force. Earth's magnetic force. And the third one is earthquakes, or we also call it as seismic. A more general name is seismic. Earthquake, energy, and forces. Seismic energy or forces, or earthquake energy or forces. Please repeat, sir, temperature part. Please, you go and watch that part of the video once again, because if everyone repeats that, please repeat temperature, please repeat density, please repeat asteroid, please repeat. Okay, all of you can have your different demands. Then this class will become a repetition class and I will never be able to complete the required syllabus. Okay. This is why Vision IAS gives you the video links also, that wherever you have a doubt, you can always go back, watch that part, and broadly fulfill your personal demand of repetition. What is the point of repeating from my side if you yourself can go and watch that part of the video? You can just write, okay, here I need to watch. Okay, because each of you will have different locations where you would want me to repeat, and I hope you understand there are more than 200-300 people in the class. If everyone demands this way, sir, please repeat this, please repeat that, class will become next to impossible. Okay, so please do cooperate. Wherever you want me to repeat, and you know this is already recorded, please write in your copy. You can see the time. This time, around this time, I need to go back and watch the video again and write. Okay, so please don't ask me to repeat. Alright, and if you have any doubt, you ask the coordinators. If they needed, if they would need, they will send it to me. Okay, is that okay? That's how these classes can go smoothly. Otherwise, it becomes very difficult. And as you can see, some of your smaller doubts I am already taking here and there. Okay. Now I am also getting this demand from some of you. Okay, sir, dictate slow, and probably that's why you are getting this repeat also. I need to know at this point, whatever I'm dictating, how many of you so that's what happens, Mayank, that the response portal gets annoying, right? For me also, because I get such requests which are difficult for me to repeat and all. Okay. Now, how many of you are comfortable writing the way I'm dictating? I just need a yes, sir, right? And no sir from the ones who don't feel comfortable the way I'm saying. You have to keep in mind that I am dictating at the pace that I want you to write so that you are able to write the mains. I hope you know from today mains are starting. The biggest problem that mains people feel is not many times that they don't know the answer. Many times they are not able to write, the answer sheets completely. They generally come back and say, sir, we were not able to complete the paper. Okay, we were not able to complete the paper. We were not able to write fully. And the only reason is because they were not writing fast. Okay. And in the classroom, you must learn how to write fast. If you are not able to write in the classroom, right, then it will become very difficult. And I know what pace I should be dictating at, right? So if you are not able to write, that is generally your problem. It is not the problem in general with all, because as you can see on the response portal, the pace is perfect. Yes, sir. Yes, sir. There are hundreds of students who are writing. Yes, sir. Okay. So and I want all of you to write, right? Please do, because I'll be counting how many of you were writing. Yes, sir. Okay. And how many of you are writing not comfortable? That also I want. And I know how many students are there in this class. So everyone should respond, right? That how many of you are comfortable the way we are writing. Okay. And the ones who are not should know that they should also write fast now, because you can see how the other students in the class, they are your competition and people like them. If you will not be able to write, then you will not be able to complete your class and you will not be able to complete your mains papers or your answers. This will always remain a problem with you, right? Maybe you have not been writing for years, but this is IAS exam. You have to write. There is no other way. Okay. So, sir, you are dictating perfectly. I'm totally okay with it. Most of you are okay, as I can see. But most of the students are okay with the dictation. And very few people are there who are saying, sir, I'm not comfortable, right? Or repeat, right? So, see, you can see dictation speed is fine, sir. And this portal is consuming so much time. Please ignore and move. We will. Don't worry, Saurabh. This is what I have to. So that's why I'm doing all these exercises in the very initial classes. Today is my first class with you online. So I'm doing this exercise so that most of you also become comfortable and understand that sir might not respond to what you are writing on the portal if it is not relevant. Okay. Because this is what I have to do. Otherwise the class never goes on. Okay. But many times if I start it from the very beginning, students feel sir is not reading on the portal and this is not useful. You should learn how responsibly we have to attend these online classes. Okay. And you should learn how to write fast. You must. Okay. And if you are not able to write, then you should write this part. I have to go back and write from the video. I will not stop. I will not repeat. Is this okay? Because most of the students are perfectly comfortable. If 80% of the students are comfortable, for 20% student, I cannot reduce the speed. Then those 20% have to catch up because you are competing for the exam. Is this okay? Please do understand. Right? So please write at your home also so that your writing speed becomes okay. Some of you are saying, sir, please put off this response portal and ask only when you are. So response portal, I don't put off, don't worry, and I would start neglecting. And if I neglect, don't come to this feeling that sir is deliberately or sir is not listening to my question. It is not against your question. I will only answer things which I need. And I'm telling you now, gradually, that this should settle in you. Okay, that I will also neglect your questions many times deliberately. Okay, and don't go on complaining later on, sir, you are not listening to my question, you are not seeing my class questions, etc. Right? You can see yourself, this portal is disturbing this thing. Sir, very good dictation, no problem. So most of the ones who have this problem can totally understand. Okay. Right? So you can see those many answers which have said they are comfortable. So don't come back and ask me, sir, please go slow. I will not. Okay. Please don't ask. And the doubts, if I don't feel them relevant, I will not answer. If I find them very basic, I will not answer. Please send those doubts which I don't answer to your coordinators. They might help. And if they need, they will send it to me. Okay. I have been told by the institute that I should be answering only the questions coming from the coordinators. I should not be answering any of the questions coming from the student. Okay. So keep this in mind. Okay. So anyways, come back. Good. Good. That's okay. Adarsh, 15 minute laga hai, but that is needed. Okay, and you are upscale. Very good. You are upscale aspirants, not group D aspirants. That you are applying from some clerk job that you should be writing slow and all that. ठीक है, थोड़ा समझो यार. IAS exam is not very easy, so you have to work fast. Okay, come back. Very good. Let's get back to our work. Okay, and hopefully I have made myself clear how I'll be conducting the classes. So please remain focused. Come back. Now, so when we talk of these gravitational forces, Earth's magnetic forces, Earth's seismic energy or forces, these are the forces that uh, okay. So when we have to talk of these, okay, gravitational force, Earth's magnetic force, and Earth's earthquakes or seismic energy, how do they tell us about the Earth interior? This is what we have to understand. These are the three forces which are there coming from the inside the Earth, and they are helping us understand the Earth interior. Because they are coming from inside the Earth, so they help. How? The gravitational forces, when we talk, let us take one by one. For example, when we take the gravitational force, how does the gravitational force help us understand the interior? Gravitation. So I want you to write this down. The gravitational force is mainly due to the mass inside the Earth. Gravitational force is mainly due to the mass inside the Earth. Full stop. As we know that the mass inside the Earth keeps varying, as we know that the mass distribution, like this way, as we know from our observations, as we know from our observations, right this way, as we know from our observations that the gravitational force, as we know from our observations that the gravitational force on the surface of the Earth, as we know from our observations that the gravitational force on the surface of the Earth keeps varying slightly from place to place, keeps varying slightly from place to place. Hence we can also conclude that the mass distribution inside the Earth must also be mass distribution inside the Earth must also be varying slightly from place to place, must also be varying slightly from place to place. And hence wherever the value of gravity is lesser, wherever the value of gravity is lesser, wherever the value of gravity is lesser, that implies that just below that region, lighter material, just below that region, lighter material is there inside the Earth. Lighter material is there inside the Earth, and wherever gravity value is higher than average, wherever gravity value is slightly higher than average, gravity value is slightly higher than average, comma, there there must be denser material inside the earth. Below that region, there must be denser material inside the earth below that region. Okay, denser material inside the earth below that region. Right, so this is how the gravitational force of the earth helps us understand the interior of the earth. Okay, so gravitational force understood. Now, Earth's magnetic field. Earth's magnetic field. Let's come to this. How does the Earth's magnetic field help us understand the interior of the Earth? Next, how Earth's magnetic field help us to understand the interior. So write down how Earth's magnetic field help us to understand the interior. So write down under this that Earth's magnetic field is mainly due to mainly created due to electromagnetic principles, mainly due to electromagnetic principles. Electromagnetic principles, which simply means, what does it simply mean? Electromagnetic. I'm not going to explain you electromagnetism and Maxwell's equation, etc. वो सब नहीं पढ़ना है. Which simply means, what does it simply mean? Let us write. Which simply means, electromagnetic principle, which simply means that inside the earth, the minerals present inside the earth, the minerals present can carry electric currents, or can conduct electric currents, and also have magnetic properties. And the minerals also have magnetic properties. Full stop. And the minerals also have magnetic properties. Full stop. And from full stop. Then, and from our scientific studies, we already know. Which minerals have such properties. Scientific studies, we already know which minerals have such properties. Which minerals conduct electricity and which minerals have magnetic properties. Which minerals have such properties. Hence, based on the Earth's magnetic field, based on Earth's magnetic forces, and differences in their strength, magnetic force and the difference in its strength, magnetic force strength, and the difference in its strength, we can predict which minerals should be there inside the earth. Which minerals should be there inside the earth, comma, how they should be behaving, mineral should be there inside the earth, comma, how they should be behaving, and also and also how they should be varying, in the distribution inside the earth, how they should be varying in the distribution inside the earth. Okay. I guess the class is still online. I'll give you people a 10-minute break here, 15-minute break, right? Let's take the 15-minute break that we are supposed to take at this place. And let me figure out, there is some light related problem. Okay, power backup. So let me just figure out that problem and I'll be back in 15 minutes. Right, so I'll give you a break here itself directly. The break that we are supposed to take in the class, I'll give you that break here. And let us see, let me just figure out this technical problem, and 15 minutes. So it is 10:22. We'll take the break at up to 10:37, 10:38. And let me just figure out this technical problem and then we'll start from here. Okay, because of this COVID thing, we are conducting the classes from home. So we have set up this thing, but I need to slightly look into it. Okay, so just give me 10 minutes break and we'll come back. 15-minute break. Okay, so let us take a quick break here. Okay, technical team. Okay, so most probably there won't be any problem, but if there are, so just cooperate. Okay, that's okay. Technical problems do keep happening. At least we are able to conduct the classes. That's a good thing that we have. Okay, by God's grace. So let us continue for the time being, and let us say if at all any problem is there, we'll handle. Okay, don't worry. So now let's start from where we were. Okay, so as I can see, Vineet sir and Farhan sir, we are all set to go. Now, so I was talking of the energy sources or the forces from inside the earth, and we saw in that the first one, energy from earth's interior, and we saw that how the gravitational forces and the magnetic forces help us understand the interior, because we can make out what type of magnetic material is there or what type of other minerals are there, magnetic or electric conducting minerals are there, and that based on the magnetic variations on the earth, we can figure out how they are differently placed. Now, the third force that we have is the seismic force, seismic energy or force, okay, which we also call as the earthquake force, also called as earthquake force or energy, the earthquake force or the earthquake related energy. Okay, so first we have to slightly understand what do we mean by earthquake force or earthquake energy. Okay, so what is the earthquake force or earthquake energy? Let us try to briefly get a sense of it. So when we say the earthquake force or the earthquake energy, first we have to understand, write down the subheading under this, how earthquake or seismic energy is created. How seismic energy, put that, write that thing, how seismic energy is created. Earthquake forces are created. Okay. You see here. You can see this is the land. This part is the land, and this is the interior of the earth. Okay. The earth has been cut like a block so that you can understand. So in this you can see that many times in the interior of the earth, below the land, this is the land, below the land, in the interior of the earth, at some places, due to the movements, first understand, don't write, due to the movements inside the earth, some compression or some tension might be created, because inside the earth movements are taking place. Okay, if they are taking place, we know now. So because of those movements inside the earth, some compression or some tension builds up. Okay, and hence because something is pushing, so compression, or something is pulling, so tension is built up. Because of that, some energy or force is stored in some location. So for example, let us say in this kind of a region, some energy or force will be stored. So because of this continuous millions or hundreds of millions of years, energy is getting compressed and compressed. That region is getting compressed and compressed. So energy stored in that region. Or if that region is continuously pulled, energy stored. Like the rubber. The way on a rubber, if you push it too much or if you pull it too much, energy is stored. So energy will be stored that way. So what is this energy? The energy is stored due to the movements inside the earth. Okay, the energy is stored in the upper rocky region of the earth's surface. The upper rocky region that we have, below which we have magma. So in the upper rocky region of the earth, this energy is stored. Okay, in the upper rocky region, this energy gets stored. And this energy, as it gets stored, right, over a period, and if the compression or the tension is too much, then this might suddenly get released. Suddenly it might break. Something like a breaking might happen, and it might release the energy, right? Now, the place where the energy gets stored. So this is the surface of the earth. This one, upper part is the surface, and this is the interior. So the place where the energy gets stored, we call it as the focus of the earth. Why tension or compression happen? As I said, because of movements inside the earth. Why are the movement happening? We know movements are happening. You will understand gradually why they are happening. Okay, that's what we have to understand. But we know there are movements inside the earth. Okay, as of now. And because of those movements, compression or tension is happening. Because of that, energy gets stored. Right? So something like this. So the place where the energy gets stored, as you can see here, is known as the focus. Okay, some of those whys we will answer gradually. So the focus is where the energy gets stored. And from there, if it becomes too much, then it gets released. Sudden release happens. So this energy gets suddenly released. Okay. And when this energy gets suddenly released, energy travels in the form of waves. We know this. Okay. So once this energy is suddenly released, it releases from this focus region and it travels as waves in all directions. So from inside the earth, in the rocky region of the earth, okay, which is above the magma region, we have seen earlier, understood all that earlier. From that rocky region, top rocky region, we have energy stored, and that energy gets suddenly released. Okay, and when that energy gets suddenly released, it travels throughout the body of the earth. Okay, so if I draw simultaneously, what we get is that suppose this is the earth, and somewhere here, let us say somewhere here, the energy is stored. Okay, this is the focus, and from the focus, let us say suddenly the energy is released. So when the energy gets released, it will travel in all directions. When this energy gets released, it will travel in all directions in the body of the wave. It is like light travels in the room in all directions, right? You must have seen the light waves. Light, if you put a bulb in the room and you glow the light, it travels inside the room in all directions. Same ways, this energy is also expected to travel in all directions inside the earth. Something like this. So this energy is what we call as seismic energy. Okay, so this energy which is stored, I'll dictate, don't worry. This energy is called a seismic energy, and when it travels inside the body, we call it as seismic waves. When it is traveling as wave, we call it as seismic wave, and when it is traveling inside the body, we call it as seismic body waves. What do we call these waves which are traveling inside the body? We call them as seismic body waves. Please do draw this diagram with me. So this is what we mean by seismic body waves. Okay. So if you see in this diagram, from the focus, these yellow and all these colored lines that are traveling, they are the seismic body waves which are traveling inside the body. So they are first traveling in the body of the earth. Below also, you can imagine the whole thing very big. So they are traveling from here in all direction in the body. So we call it as the seismic body waves. Now, these seismic body waves, as they are traveling, you can understand that they will reach the surface in all directions. On the surface of the earth, gradually they will reach the surface of the earth. They will travel in the body, inside the body, and then reach the surface of the earth. Wherever they reach the surface of the earth, okay, there, once they reach the surface, for example, if they are reaching the surface here and they are, this energy is losing its self minimum and reaching the surface, minimum energy is lost for this wave because it is traveling very less in the body and reaches the surface here. Okay, so wherever the seismic body wave is traveling minimum distance and reaching the surface, that top surface we call as the epicenter. Epicenter is the point just below, above the focus on the surface of the earth. Just above the focus on the surface of the earth, the place is epicenter. For example, just let's say where I'm standing, just below me, let us say 100 kilometer below me, the focus is there. Okay, and from there some seismic energy is released. Okay, so the place where I'm standing on the ground becomes the epicenter because the focus is just below me. Okay, do you get it? So epicenter is this place. Okay, epicenter is where the energy from the focus traveling minimum and reaching the surface of the earth. Okay, I'll dictate all this, don't worry. Once it reaches the epicenter, so up to the epicenter, which waves are traveling? Seismic body waves. Okay, and seismic body waves are traveling in all direction like this. Now from this epicenter, on the surface of the earth, another wave is created, which you can see here. Wave-like formations are there on the surface. So from the epicenter, another wave is created on the surface of the earth. First, focus, the energy is there. When it suddenly releases, it travels as body waves, seismic body waves. Seismic body waves reach vertically above at epicenter on the surface of the earth. On the surface of the earth, from the epicenter, surface waves are created. It is like throwing stone on the water, lake. So when you throw a stone in the lake, on the surface of the lake, a wave is created. Like that, from the epicenter, wave is created on the surface of the earth. Right? These waves which are created on the surface of the earth would be for example like this. On the surface of the earth, wave will be created. This wave that is created on the surface of the earth, we call it as the seismic surface waves. Seismic surface waves, or also called, we call them as the earthquake waves. Earthquake waves. Why? Because they cause the earthquakes. They cause the earthquake. So complete this diagram. Seismic body waves and seismic surface waves, also called as earthquake waves. So seismic surface waves are created from which point? Epicenter. Epicenter. And epicenter is vertically above the focus. The epicenter point is vertically above focus. Focus is where the seismic energy starts from in the interior of the earth. So from the focus in the interior of the earth, seismic energy starts as waves. It travels as seismic body waves in the whole body of the earth. When it reaches the epicenter vertically above, from there surface waves are created on the surface. These are the surface waves created on the surface. They travel on the surface, which cause the earthquake. So once you have drawn this much, then I'll dictate and we can write. Just draw this much and then I'll dictate. Just draw it fast. Okay. Tension and compression, nahi, compression, Rahul. Okay. So anyways, come back. Hopefully drawn this much, everyone has drawn this much. So once you have drawn, now write down. Very good, write down. That. What is the subheading? The subheading is seismic waves, seismic energy and seismic waves. Seismic energy and seismic waves. Write down. In the upper rigid rocky region, in the upper rigid rocky layer, in the upper rigid rocky layer of the earth, upper rigid rocky layer of the earth, or slightly below it, just slightly below it, upper rigid rocky layer or slightly below it, comma, due to movements inside the earth, due to movements inside the earth, due to movements inside the earth, within bracket discussed later, we'll discuss the movements later, due to movements inside the earth, within bracket discussed later, bracket closed, large amount of tensional or compression energy is stored. Large amount of tension or compression energy. Large amount of tension or compression energy is stored. Tension or compression energy is stored. Known as seismic energy. Known as seismic energy. Also, this is stored at the region known as focus. This is stored at the region known as focus. This is stored at the region known as focus or hypocenter. Region known as focus or hypo, H-Y-P-O, hypocenter. Focus or hypocenter. Region known as focus or hypocenter. In Earth's interior. Focus or hypocenter in Earth's interior. So this region is called as focus or hypocenter also. This is the other name I'm dictating here. Hypocenter in the interior of the Earth. Full stop. Next line. When this energy becomes too much, when this energy becomes too much, when this energy becomes too much, it gets suddenly released. It gets suddenly released. Suddenly released in the form of seismic waves. In the form of seismic waves. S-E-I-S-M-I-C. Seismic waves. And travels through the body of the earth, through the body of the earth, or in the body of the earth, travels in the body of the earth in all directions. Travel in the body of the earth in all directions. Travels in the body of the earth in all directions as seismic body waves. Underline this. As seismic body waves in the body of the earth in all directions as seismic body waves. Underline this. Seismic body waves. Just like light travels from the bulb. Light travels from the bulb in all directions inside a room. Light travels in all directions. Light travels in all directions from the bulb comma, inside a room or in a room. Full stop. Full stop. As the light of the bulb reaches the walls of the room, as the light of the bulb reaches all the walls of the room, as the light of the bulb reaches all the walls of the room, all the walls or surfaces of the room, light of the bulb reaches all the walls or surfaces of the room. Same ways, seismic body waves also are supposed to reach on all the surface of the earth, after passing through, supposed to reach, underline this word supposed to reach on all the surface of the earth after passing through the body of the earth. After passing through the body of the earth. Full stop. The seismic body waves also reach the surface of the earth. Seismic body waves also reach the surface of the earth just above the epicenter, just vertically above the epicenter, just vertically above the focus. Just vertically above the focus. Just vertically above the focus by traveling minimum distance in the body of the earth. By traveling minimum distance in the body of the earth. Traveling minimum distance in the body of the earth, and hence losing minimum energy, in traveling in the body. And hence losing minimum energy in traveling in the body of the earth. Losing minimum energy in traveling in the body of the earth. Also, this point vertically above the focus on the surface of the earth This point vertically above the focus, this point vertically above the focus on the surface of the earth is known as epicenter. Is known as epicenter. This point, epicenter. And from the epicenter, surface seismic waves are generated. Surface seismic waves are generated from the epicenter. Surface seismic waves are generated on the surface of the earth. Surface seismic waves are generated on the surface of the earth, which cause the shaking of the earth's surface. Surface seismic waves are generated on the surface of the earth, surface seismic wave on the surface of the earth, which cause the shaking of the earth, known as earthquakes. Cause the shaking of the earth, known as earthquake. Known as earthquake. Hence, earthquakes are mainly generated by the surface seismic waves. Earthquakes that we feel are directly generated by seismic surface waves. Seismic surface waves. But the seismic surface waves do not travel. In the interior of the earth. Seismic surface waves do not travel in the interior of the earth. And they travel only on the surface of the earth. Okay? They travel only on the surface of the earth. Full stop. Hence, only the seismic body waves travel through the body of the earth. Only the seismic body waves travel through the interior of the earth. Travel through the interior of the earth. Travel through the interior of the earth. And hence, only the seismic body wave tell us about the interior of the earth. Okay, so what tells us about the interior of the earth? Not the whole, you can say, earthquake, not all the seismic waves. Like the seismic surface wave does not tell us about the interior of the earth. What tells us about the interior of the earth? Only the seismic body waves tell us about the interior of the earth. Is this clear? Okay. So we come to know of the interior only from the seismic body waves. Clear? All right. Hopefully understood. Right. So now we have to understand the characteristic of seismic body waves. Hopefully you have written. Then characteristics of the seismic body waves. Give me just a minute. I'm trying to write on the PDF on the tablet, because even if the power goes, then whatever we write on the tablet remains with me. It doesn't get deleted. Whereas if I write on the screen, then if the power problem is there, then the screen refreshes. So everything that I've written on the screen is gone. Okay. So just help me. Hope you can coordinate and cooperate this much that we if I write on the PDF, that is also, and it will be visible to you exactly the way it is visible to the other thing. Okay. Right. So all right. So I'll use slightly darker shade, slightly, so that the background doesn't become too dark or too bright. The foreground doesn't become too this thing. So now let us see. So characteristics of seismic body waves. Characteristic of seismic body waves. Okay. So what are the characteristics of seismic body waves? There are two types. First, types. So we have two types of seismic body waves. We call them as the primary or P waves and secondary or S waves. Right? So this is the type of body waves that we have. We have the P wave as well as the S wave. All right. So yeah, so the P wave and the S wave. These are the two types of waves that we have. Okay, and just the screen connection slight. Yeah, so we have the primary P waves and the secondary S waves. This is the type of waves, two types of waves. What is the difference between the two types of wave? The P wave is a faster wave, faster. So I'll go on writing the characteristics. Faster wave. The P wave is a faster wave. All right. Whereas the S wave is a slightly slower wave. Nidhi, the body waves are created, the surface waves are created by all the body waves region, but the strongest are created at the epicenter. The strongest surface waves or the strongest earthquake waves are created from the epicenter. All right. So the P waves are also the faster of the seismic waves, and the S waves are the slower of the seismic waves. Okay. So S waves are, so speed if you see, speed. The other one is slower, 1. This is the first characteristic of the P wave and the S wave. Then the second characteristic of the P wave and the S wave is in terms of medium in which they can travel. Medium in which they can travel. The medium in which they can travel. Okay. So what are the mediums in which the P wave and S wave can travel? Okay. When we talk of the mediums in which the P wave and S wave can travel, we find that the P wave can travel in all mediums. All mediums. It can travel in all mediums such as solid, liquid or gas. The P wave can travel in all mediums, solid, liquid or gas. Okay, there is no problem of which medium it can travel in. It can travel in all medium, the solid, liquid and gas. Whereas the S wave can travel only in solid medium. Thus S wave can travel only in the solid medium. Is this clear? So S waves travel only through the solid medium and they are not able to travel through the liquid medium or the gaseous medium. Okay, so S wave travels only through solid medium, not through liquid and gaseous medium. They stop, the S wave stops in the liquid or gaseous medium. Please do write if you want. S wave stops in the liquid or gaseous medium. S wave stops in the liquid or gaseous medium. Okay. Now, next, there is a character with respect to the bending of the waves. Bending of waves. Okay, bending of waves, right? So, how do they bend? Let us see. The S wave bends, S wave bends only when density of medium changes. S wave bends only when the density of the medium changes. Okay, S wave bends only when the density of the medium changes. Medium means the part through which it is traveling. Okay, when you are talking of the interior of the earth, so the interior of the earth becomes the medium. Okay, and the medium might be in different states, solid, liquid or gas. Okay. So S wave bends only when the medium changes, whereas the P wave bends. When do the P wave bend? The P wave bends when density of medium changes. When the density of the medium changes, the P wave bends. Also, when state of medium changes from one to other. When the state changes from one to other, like solid to liquid, liquid to gas, gas to solid, then also the P wave bends. Okay? So the P wave bends when the state of the medium changes also. Is this clear? Right? So the P wave bends only also when the state of the medium changes. And it bends also when the density of the medium changes. So both when density changes and when the state changes, it bends. S wave changes, S wave bends only when the density changes. When the state changes, the S wave stops, because S wave can travel only in one state. Which state? The solid state. S wave cannot travel in liquid or gaseous state, so it stops in the other states. Is this clear? Hopefully this much is clear. No major doubts. Yes or no? Right? Okay. So this is how the P wave and the S wave characteristics are there. Right? They bend, they change, they stop, they become faster or slower, all these characteristics. Okay. So now these characteristics of the P wave and S wave, you can write, once you have written this much, then you can write these characteristics of the P wave and S wave. These characteristics of the P wave and S wave help us in better understanding. Help us in better understanding the interior of the earth. Help us in better understanding the interior of the earth. As discussed below. As discussed below. Okay, so from these characteristics, we'll try to understand. Okay, so as these characteristics will change, they will change because they are traveling through the medium, right? So when they will change, when they travel through the medium, they change, and when they reach the surface of the earth, we can study. Now you can write here one more thing. When the seismic body waves reach the surface, when the seismic body waves reach the surface of the earth, seismic body waves reach the surface of the earth at different places in this diagram. When the seismic body waves reach the surface of the earth at different places, we can use devices such as seismographs at different locations. Suppose these are the devices, right? These dots, these circles are the devices. We can use devices such as seismograph at different locations. Devices such as seismograph. The name of the device is seismograph. Seismograph at different locations to study and know, to study and measure, these seismic body waves reaching the earth's surface. To study and measure these seismic body waves reaching the earth's surface. Study and measure the seismic body waves reaching the earth's surface. So at different places we can put seismograph. They are constantly put in different research laboratories of the world, and when the seismic waves are created, we measure at these places. Okay, and right, from this data collected, we come to know of the changes in the seismic waves. We come to know about the changes in the seismic waves while traveling through the body of the earth. Come to know about the changes in the seismic waves while traveling through the body of the earth. So when these seismic waves are traveling through the body of the earth, what changes have taken place in the seismic waves? That we can measure and hence predict about the interior of the earth, or the body of the, you can say interior of the earth, and hence predict about the interior of the earth. Hence predict about the interior of the earth. Okay, so this is how we come to know of the interior of the earth from seismic waves. This is how we come to know about the interior of the earth from the seismic waves. Come to know about the interior of the earth from the seismic waves. All right. So hopefully this much is clear about the. I think ये color थोड़ा ज़्यादा dark हो गया. So let me. All right, this was good. So I hope you understand how the seismic wave. First we know the characteristics, then we measure the seismic wave at different places on the earth for any earthquake. The seismic body waves we measure on the different places. When from that measurement we come to know what changes have happened in the seismic wave when they were traveling in the body of the earth. From that we can predict what kind of part in the body of the earth must be there, because of which these changes have happened. Okay, so this is how we come to know of the interior of the earth. Clear? Okay. So now let us go beyond this and try to understand further. Okay, so first, role of S waves in understanding interior of the earth. Role of S wave in understanding the interior of the earth. Let us first understand this. What is the role of S wave in understanding the interior of the earth? Okay, so please see. Now first we write parts of it. Under the subheading also we write some more subheadings. Okay, what are the subheading? First, how we expect S wave to travel in Earth's interior. How we expect S wave to travel in Earth interior. That is the first part. In the role of the S wave, how we expect the S wave to travel in the interior, travel in Earth's interior. Right? That I will draw, and I want you also to draw with me. Okay, simultaneously. So if this is the Earth, like this, okay, and let us say that this is the epicenter, sorry, hypocenter or focus. Okay, so we expect the S waves to travel in all directions, and we know that the density inside the Earth slightly varies. As you go deeper, the density becomes more and more. So we expect the S waves to bend. Expect the S waves to bend and travel like this. And the same we expect from P waves also. Okay, so this is what we expect from the X wave. How we expect S wave to travel in the Earth's interior. We expect the S wave to travel like this in the Earth interior and reach all surfaces of Earth after traveling through interior of Earth. Reach all surfaces of Earth after traveling through interior of Earth. Okay, this is what we expect. Hopefully this is clear. This is what we expect. Now what we expect and what we observe in reality might be different. Okay, so what we observe in reality is different from what we expect the S waves to behave like. Okay, so we'll see how the practical real observation is different from this. That's what I'll draw next. Okay. Hopefully this is done. This much everyone has drawn. No major doubts. Okay. So everyone has hopefully drawn this and clear. This much is clear to everyone. Right? That this is what we expect the S waves to behave like. Now, let me draw the next diagram. How B part? How practically S waves travel? How practically S waves travel Now practically S waves travel. This is the next thing. As observed by different seismographs across the earth. Right. So for any earthquake, when we see how the seismographs are observing those S waves, what do they observe? Is something that we are going to draw now. For any given earthquake, what we observe is that what is the focus? Let us say here is the focus. The focus could be anywhere with respect to that we are drawing. This is the focus, okay, and this is the epicenter. Just above it. Right, the focus and the epicenter. Hopefully this is clear. Now one thing I would want you to add in the previous diagram slightly. In this diagram, also if this was the focus and this was the epicenter, please draw in that order. Epicenter, okay, epicenter. Previous diagram. Earthquake, the focus and the epicenter, and obviously somewhere here will be the center of the earth. Right, in the center, this where somewhere there you will have the center of the earth. So this is earth center. Earth's center. Okay. So if we measure, now please first understand this, if we measure from epicenter as 0 degree and the center, if we make a line and then we go on measuring. So if we say that the epicenter is 0 degree, then obviously the opposite point becomes 180 degree. This point becomes 180 degree. 0 degree, so 180 degree passing through the center. Okay, and we expect that S wave should reach the surface from 0 degree up to 180 degree everywhere. We can say this, that we had expected. What were we expecting? We were expecting that we have already written everywhere. So all I'm saying is in terms of angle. I'm saying that if we consider from center to the earth, epicenter to be 0 degree, then from 0 degree up to the opposite side of the center up to 180 degree, from 0 to 180, everywhere I would expect the S wave to reach the surface of the earth. This is clear. This is what we have, right? So if you want, you can note this down, that we expect that considering the epicenter as 0 degrees, considering the epicenter, if you want, you can draw this also, 0 degree epicenter, 180 degree here. Considering the epicenter as 0 degree, and the opposite point of the earth as 180 degree, opposite point of the earth as 180 degree, opposite point on the earth as 180 degree, comma, the body waves should reach the surface of the earth. The body waves should reach the surface of the earth. Body waves should reach the surface of the earth everywhere from 0 degree to 180 degree. Everywhere from 0 degree to 180 degree. Okay. Now come to this diagram. Then complete this diagram and then we'll write further. Now what we really find, how practically S wave travel, this is what we'll see. So again, in the diagram, I'm drawing the epicenter and I'm writing it as 0 degree, drawing the center and the opposite point at 180 degree, right? Something like this. 0 degree, center, 180 degree, something like this. Now, what we observe is that S waves reach the surface of the earth from 0 degree up to S wave, first draw, then I'll dictate. S wave reach the surface of the earth from 0 degree up to 105 degree. From 0 degree up to 105 degree, reach the surface of the earth from 0 degree up to 105 degree in all directions. And they reach the surface of the earth from 0 degree up to 105 degree in all directions. Okay. So S waves reach the surface of earth. S wave reach the surface of earth from 0 degree to 105 degrees in all directions. Okay, but from 105 to 180 degree, S waves do not reach the surface of earth. S waves do not reach the surface of earth. From 105 to 180 degrees, S waves do not reach the surface of earth. And this region, right, this region is called as S wave shadow zone. This region is called as S wave shadow zone. Is this okay? Now you don't even have to ask me, sir, please थोड़ा side हो जाइए, because मैं अभी side में खड़े होके ही draw कर लेता हूँ. Okay, that is the benefit of drawing here. So this region 105 to 180 degree on the surface of the earth with respect to the epicenter as 0 we call as S wave shadow zone. Okay, so what does this mean? That if, for example, the S wave is like this, so the S wave is able to travel something like this. The S wave is able to travel something like this. Up to here it is able to travel. But in this region, whatever S waves are there, they are not able to travel into this region. They are not able to pass this region. Yes or no? So this means that the S waves are able to pass only this much of the region and hence they are able to reach the surface. But S waves are not able to pass this region and hence they are not able to reach this region. Right? Full stop. So once you have drawn this, then write down. That once you have drawn this, then write down. The practical observation with respect to S waves traveling. Practical observation with respect to S waves traveling. Practical observation with respect to S waves traveling is that practical observation with respect to the S waves traveling is that for a given focus and for a given focus, which means wherever the earthquake is coming, for a given focus where the earthquake is coming or where the seismic waves are generated, you write this way, for a given focus where the seismic waves are generated, where the seismic waves are generated, and considering its epicenter as 0 degree, and considering its epicenter as 0 degree, considering its epicenter as 0 degree, that's what we are coming to, Divya, I'll tell you. Considering its epicenter as 0 degree, comma, the seismic body waves generated there, the seismic body waves generated in this case, seismic body waves generated in this case seismic body waves generated in this case reach the surface of the earth reach the surface of the earth from epicenter within bracket 0 degrees from epicenter within bracket 0 degrees bracket close only up to 105 degrees, only up to 105 degrees in all directions, only up to 105 degrees in all directions on the earth's surface, only up to 105 degrees in all directions on the earth's surface from the given epicenter, from the given epicenter. Full stop. And full stop. And the region from 105 degrees up to 180 degrees, the region from 105 degrees up to 180 degrees, region from 105 degrees to up to 180 degrees, everywhere, 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 does not observe the S waves, does not observe the S waves to reach the surface of the earth, does not observe the S waves to reach the surface of the earth. Does not observe the S waves to reach the surface of the earth. Hence this surface region where the S waves do not reach this surface region, where the S waves do not reach for the given focus and epicenter, for the given focus and epicenter within bracket for the given earthquake, for the given focus and epicenter within bracket for the given seismic activity or earthquake, for the given seismic activity or earthquake, for the given seismic activity or earthquake, bracket close, is known as the S wave shadow zone, is known as the S wave shadow zone of that earthquake, known as the S wave shadow zone of that earthquake. S wave shadow zone of that earthquake. Okay, full stop. The angle, next line you're writing, or next paragraph you're writing, the angle 105 degree, the angle 105 degree does not change the value of the angle. You write this way, the value of the angle 105 degrees, the value of the angle 105 degrees, the value of the angle 105 degrees does not change with respect to any earthquake taking place anywhere. With respect to any earthquake taking place anywhere on the earth. The value of the angle 105 degrees does not change with respect to any earthquake taking place anywhere on the earth, considering its epicenter as 0 degrees. Considering its epicenter, the epicenter of that earthquake as 0 degree for that case. Considering its epicenter as 0 degree for that case. Okay. Right? So this is what we understand. Now, what does this mean? Let us try to see. So what we are saying is that let us say if this is the earth, okay, this is the earth, like this. And on this earth, what different epicenters are there? Okay, for example, this is one, let me say the focus or the epicenter, whatever you say. Okay, so let us say this one, I'm taking here, somewhere here. So for this, it will be something like this, right? 0 degree and 105 degree, 105 degree with respect to this. Same ways, if I take another epicenter somewhere else, so with respect to that, it will again be 105 degrees, something like this. And if I go on drawing for different earthquakes the same ways, okay, taking place different locations. And so on. Right? If I go on drawing like this, ultimately what you will get is that you will get in the center a spherical region, something like this in the center. After a period, if I go on drawing like this, after a period you will get a spherical region in the center like this. Like this, where you will find that the S waves are not able to pass through. Something like this. You will get a central region through which you will find that the S waves are not able to pass through no matter. Okay. So I can go drawing n number of earthquakes. Whichever earthquakes I take, with respect to that earthquake, I find that there is a central region always through which the S waves are not able to pass through. Do we get it? And the angle of this always remains. Why does the angle always remain 105 degrees? Because it's a concentric. In the center of the earth, there is this circular region or spherical region through which the S waves are not able to pass through. Okay. Okay. So ठीक है, grammatical होगा सुमित, please figure out and check whichever way you understand. I hope what the concept that I'm trying to make you understand, you should understand. If by mistake anywhere rather than earthquake I might have said earth, that you can correct yourself slightly. Move in interior of earth or also on the surface of earth. S waves travel only in the interior of earth and reach the surface of earth the same ways that light travels through the room and reaches the walls of the room. Okay, same ways. So this region, the S wave is not able to pass through. And what does this imply? Why, in which kind of region S waves are not able to pass through? We know that the region that S waves are not able to pass through must be either liquid or gaseous. And in the interior of the earth, there is no possibility of a gaseous region. Why? Because gases are lighter than solids. And in the interior, you can't have a very gaseous region at the center and outside it very dense material. Okay. Otherwise, these gases would have escaped by now and come to the atmosphere. So there is no possibility that we still have gas, which means this region must be liquid. Now, can liquid be denser than solid? Yes. Gases cannot be denser than solid, but liquid can be denser than solid. For example, water is denser than wood. Mercury is denser than many other solids. Okay, so liquid can be denser than solid. So in the center of the earth, hence we have this kind of a region, okay, this spherical region which is in a liquid state and through which S waves are not able to pass through. Therefore, they are not able to reach on the other side. Do we get it? Is this clear? Sir, why angle 105 degrees? That is always fixed. So this is what we observe, that the angle 105 is due to this spherical region. Because it is a spherical region, so always perfect spherical, it's a near spherical region. So always the S wave, that is the symmetry of this drawing, you can say, because of which they are not able to pass through. Why they don't go beyond? Because the region, for example, if they are going this way, let us say from this here, it is trying to go. It is the liquid region, so it will not pass through. It will die. S wave don't pass through liquid region. I hope you understand. Right? So that's why they don't go. Adarsh and others who have asked, this is why they don't go through this liquid region. Okay. So is this clear? So there are 2-3 things that I said. What are the things? One, in this region, they are not able to pass through, as you can see. Why they are not able to pass through this region? Because this must be either in a liquid or gaseous state. Now, second, is gaseous state possible? No, because gases are always lighter than solids. So, in the interior of the earth, you can't have a denser gaseous region. Can it be liquid region? Yes, because liquids can be denser than solid. I told you the example. Okay. So, this means that this region is in a liquid state. So, that shows the S wave practical observation shows that the interior of the earth has a liquid denser region. Okay. And hence the S waves are not able to pass through that liquid denser region. Is this okay? So interior of the earth, yes, they move from 0 to 5 degrees, and in the region beyond 105 to 180, because they have to pass through the liquid region, they are not able to pass through the liquid interior, so they don't reach the 105 to 180 degrees. No, liquid does not have lighter density than Shikha abhi bataya na, wood and water. Water is denser than liquid. There are many denser than wood. So there are many liquids denser than solid. Okay, Shikha, I sound me. I told you there are some basic concepts that you people are missing. How, sir, water denser than wood? That's why wood floats on water. राहुल ऐसे क्वेश्चंस पूछोगे तो फिर मैं नहीं पढ़ा पाऊंगा. ठीक है सर, हाउ मतलब आप कितने साल के हो राहुल एंड शिखा? नॉट शिखा, आई वुडंट से, बट है ना, कितने साल का एज है आप लोग का? 23, 24, 25 साल का एज में अगर आप लोग ऐसा क्वेश्चन पूछोगे, सर इज वुड लाइटर देन वाटर, तो फिर दिक्कत हो जाएगा. ठीक है, थोड़ा पढ़ो फिर खुद. Right, S-wave shadow zone I have repeated, I can't repeat. Ranjit, please go and watch yourself. What is S-wave shadow zone? S-wave shadow zone, you have written also in your copy, Harshita and Ranjit. S-wave shadow zone is the region where 105 to 180 degrees S-wave do not reach the surface of the earth. लिखा है आपने अभी. Gases do come out because they are not in the center of the earth. They are in the outer interior of the earth. Okay, Avneet? Clear? Why P waves are similar to sound waves? ये सब छोड़ दो, sound waves और वो S waves equal to sound wave, ये सब हमने S wave, मैंने sound wave का तो बात ही नहीं किया है, not needed here. ठीक है, इतना अभी जानना नहीं है. Right? Do wave travel in straight lines? Sir, do waves travel in straight line? They travel in straight line when the medium is same density. When the density of the medium change, wave also bend. वो लिखा है ना, wave bending character. निकुंज भूल गए आप, अभी ऊपर लिखा है. See, most of you need to revise because this is new to you. Now please listen, don't go on asking questions, right, without revising. Go and revise. Whatever you have done today, many of you, many things are new. So you have to revise it 2-3 times. Go and revise one at least 2-3 times. Once you understand, revise everything, then you will understand what you have done today. Okay? Because many times you are not able to hold in your mind what we did in the first 1 hour by the next 2 hours. After 2 hours, 1 hour, you forget what you have done in the first 1 hour. Okay, so you have to revise, then things will get clear. Okay, so this is what I have to tell you now. But sir, how can we even expect S wave to reach 180 degree, because all the reflection and refraction they will be getting, because it will be impossible to reach 180 as distance too much more and density varies everywhere. See, they should always be known, Drashti Parmar, that waves which are traveling straight through the center without any that kind of which are falling perpendicular and straight, they do not bend. Only the waves which are falling at an angle, they bend. Okay, that's why in these diagrams the waves which were falling at an angle, they were bending. The straight one does not, right? Even if the medium changes, the straight waves falling straight on anything do not bend. You have to read the wave characteristic and wave refraction. Read slightly, you will understand. Drashti. Okay, do we get it? So you have to slightly revise and you will get all this. Do P waves don't pass through the center? We'll talk of that P wave. Okay, don't worry. So now write down this last part and then I'll leave you for today. Write down, hence, from the S wave, वैभव किसका है वो, आप अपने आप चेक करो. राइट, राहुल आप खुद देखो, मैं नहीं बताऊंगा. राइट, सो राइट डाउन that because S waves do not reach the reach 105 to 180 degrees for any earthquake. S wave do not reach in 105 to 180 degree for any earthquake. Hence, for any earthquake, hence it implies that there must be a concentric. Find the meaning of concentric yourself, the one who don't know. Simple चीज है, खुद ढूंढना है थोड़ा लाइफ में. Concentric, spherical liquid region. Concentric spherical liquid region in the center of the earth. Concentric spherical liquid region in the center of the earth, through which P waves are not able to pass. Through which S waves are not able to pass. And hence not reach in the 105 to 180 degree region. Not reach in the 105 to 180 degree region. Full stop. This way, the S wave studies help us understand that at the center of the earth, S-wave studies help us understand that at the center of the earth, there is a denser liquid state region. Through which S waves are not able to pass. Denser liquid state region through which S waves are not able to pass. I have drawn it here, you can see. Denser liquid state region through which S waves are not able to pass. And I'm showing that they are not able to pass. You can see, right? Not able to pass. See here, they are dying here. Not able to pass. And from the angle calculation, 105 degrees, we can easily calculate that this liquid spherical region is at a depth of 2900 kilometers. You can see here, at a depth of 2900 kilometers from the center of the earth. From the surface of the earth. That you can find from the angle calculation. That is mathematical, you can calculate and figure out. By the bending and all this, we can figure out. Is at the depth of 2900 kilometers from the surface of the earth. Right? From the surface of the earth. We call this region as the liquid core of the earth. Liquid core. We call this region as the liquid core of the earth. You can see here. Liquid core. So S wave tell us the liquid core of the earth. So the S waves tell us about the liquid core of the earth. Okay, so this is where I'll stop the class today. Hopefully this much is understood by most of you. Is this understood broadly by most of you? Yes, I know revision is needed. Many of you have not revised. So once you will revise everything that you have done today, you will understand. But hopefully everything that I was doing, while I was doing, did you understand? If you understood then when you will revise, you will understand better. Okay. So while I was doing, did you understand all this? Is this much clear? Right? So is this much broadly clear with most of you? Yes or no? I need that answer. This is the last thing I'm asking. After that, today's class is over. Technical team, is there any doubt? Classroom coordinators, is there any doubt that you want me to take up? In the meantime, I'll wait for the student answers to come. So I can see the answers coming. Yes, sir. All okay. Yes, sir. Yes, sir. Yes, sir. Perfectly. Yes, sir. Yes, yes. Right. So you have to just revise the things that you have done, small things here and there, which you people earlier did not know. Let us say related to science and all. You might have to figure out yourself. Okay. Yes, sir. Explained well. Good, good. ठीक है. अच्छी चीज़ है. Understood. मज़ा आ गया. Yes. Understood. Very good. मज़ा आया तो ठीक है. So you have to revise also. सिर्फ मज़ा ही नहीं लेना है क्लास में. Understand भी करना है और रिवाइज भी करना है. वेरी गुड. ठीक है. मजा तभी आया होगा व्हेन यू हैव अंडरस्टूड. वेरी गुड. सो एवरीवन हैज अंडरस्टूड. नाइस एक्सप्लेनेशन. वेरी गुड. गुड गुड गुड. So good to see so many students have understood. Okay. All right. So ठीक है. If all of you have understood. Sir, do we go through vision module? Not needed. Go through the NCERT and the class. You will understand. Not needed. Vision module is not needed here. Okay, so hopefully everyone has understood. Everyone is writing yes sir, yes sir. The ones who might be in doubt, you have to slightly revise. You will get it. If so many students can understand, so can you by putting slight effort. Okay, so put that slight effort today and you will understand. There is nothing that you cannot understand in this. NCERT chapter is chapter number 3 for today, right? And for next class, you will have to read chapter number 4. Okay, and in chapter number 3, don't read volcano and earthquakes right now. Don't read volcano and earthquake. Chapter number 3, only read the interior of the earth. Don't read volcano and earthquake. Then read chapter number 4, right? And later on, we'll come back to volcano and earthquake. Okay. So I've said chapter number 3, read only the interior. Don't read volcano earthquakes, and then come back and read chapter number 4. Okay. Gravity anomaly is the variations in the gravity. Very simple, which I told you that different variation in gravity will be there, and because of this, we understand that in the interior, different regions have different types of material. Okay, so what I said as variations in gravity means anomaly. Anomaly means variation. Okay, so that's it. Everyone has written. GC Leong you don't need to read right now. I don't want you to read GC Leong. Okay, and okay, okay. If you understand. No, there is no name of the place, and no, this is not any place which is fixed. It is for every earthquake, the 105 degree we measure, and that location, right? It's not that this place 105 degrees fixed, and there is no name for it also. I can't fix the technical problem. Ask the technical team to do it. Okay. GC Leong you don't have to read right now. For interior of the earth you don't have to read. Which NCERTs? Fundamental of Physical Geography. Class 11th NCERT, Fundamental of Physical Geography, that you have to read. Okay, very good. That's it. So thank you everyone. Classroom coordinators, thank you. Right, and thank you everyone else. Technical team, class over और मैं mic off कर रहा हूँ.